Before lunch, we started talking about what we were going to do to our repository. This is the style of code that I most enjoy, like delete. I love deleting code. It's so good. It feels very cathartic. Before we go ahead and do that, I want to also talk a little bit about entities. Right? We talked a little bit about our entity manager. We want to also talk about entities, right? Because all of this stuff that we're deleting from our repository, all the stuff that we're deleting from the repository is stuff that has to do with our database schema, right? Init will set up the schema. Find has to do this unmarshalling, which requires us again to know something about the schema, right? We need to know how to do a select query from this thing, what the names of the rows are, and so on. And our create and our update, right? Those all again are dependent on database schema. So what we've said so far, the stuff that we're deleting needs to be replaced by something. And what we've said is that the object should be the one true place for knowing something about our database schema, right? So what we're going to do with objects is we're going to specify a number of annotations on the fields of on the object classes themselves and on their fields. That's how we decide that they are some sort of a database entity. That's how Hibernate is able to pay attention to them. Right. So I wanted to take a quick look at that as well. We'll look at it in the Java doc to start with before we actually do anything with it. We'll just look for JPA, which is not what I want yet. JPA annotations. Yeah. Java X persistence annotation. There we go. There we go. 6. Come on. Yeah, there we go. Man. Why is it so hard to find all the things that I want? I guess it's in here. Yeah, okay. All right, that's fine. So there's a number of annotations that we use. We've already seen Entity Manager. We'll see Entity Manager Factory as well, and something called Persistence. But the stuff that I want to look at for the moment is this rather long list of annotations that is really what's going to end up driving all of our database-related stuff. Right? First, most important one is entity. Right? Any class that's going to be a database, it's going to be persisted to the database. We just mark it with the entity annotation. So very simple, right?
So the annotation is actually interfaced, right?
So that's a Java language question, right? In the Java language, there's this sort of weird syntax for specifying for declaring annotations, and that is there isn't like an annotation keyword. We say public at interface, and at interface is the weird way that Java calls annotations.
Oh, it's the standard way?
Yeah. This is Java. This is standard Java.
So whatever the annotation is, you have to put that at interface.
These are how annotations are declared. Like if you wanted to create your own annotation, you would say public at interface my annotation, right? When you annotate something, it looks just like every other annotation we've seen.
Okay, that's cool.
Right. Yeah. This is it's kind of weird, sort of little known feature, and they added this in Java 5, right? These annotations. Later on in the week, actually, when we get into custom validators, we will create our own annotations. We'll make annotations for validating some properties about our data model. Right? Okay, so entity. Basically, any object that we want to be persisted in the database, we just say, hey, it's an entity. We just annotate it with entity. How do we then say what the schema of that table is going to be, right? Entity is basically like saying this is a table, right? Like the address entity corresponds to the address table. And that table is going to have a number of what? Columns, right? So this might be a reasonable place to start, right? Column, yeah. And you can call your columns whatever you want. You know, if you want to be particular about how they're named, but you can even just say @column. You don't have to even put any of these like you know, fields in the annotation. You can just say @column, and ta-da! You've got a field. You've got a column in your table. Right?
What are those first two lines? Like there are 3 lines, right? Public @interface column.
This.
The target retention.
Oh yeah. So again, this is sort of a Java language thing, right? The way that you declare annotations. So you'd say public @interface column, but you also need to know what the annotations are applicable to, right? Should this annotation apply to methods? Should this annotation apply to fields? Should this annotation apply to classes, right? So for the column annotation, we say that the target is going to be methods and fields, and also it's very important for the Java compiler to retain these annotations in the Java bytecode until runtime, because that's how they're used, right? Hibernate needs them at runtime to be able to do anything.
So you have to annotate your annotation declaration?
Yeah. When you're creating annotations, you annotate the annotations. Yeah. It's all very circular.
But the it's not circular in the sense that the target annotation is implemented differently. For instance, it's not like the implication for that isn't implemented with another. Sure,
it is.
It is.
Yeah. Yeah. It actually is. So it's funny. Fortunately, we won't need to really worry about this. So when we want to use these annotations, right, we just say @column for our, you know, in this case we have a description column, right? So @column, and there's some other things that we might want to look at as well, like many to many or many to one or one to many, right? These specify the kinds of relationships, right? If we have entities referring to other entities. So these are, you know, there's a lot of stuff here. To be totally honest with you, I don't know what probably 80% of these do. Some of these have to do with life cycle. Some of these are for a dependency injection. For example, persistence context is something that we can't use in our setup because it's for a servlet container that supports CDI, which we don't have. But there will be a few that we'll use very commonly. The entity annotation, column annotation, right? One to one, many to many, things like that. And those will essentially determine our schema. Okay. And that's so those are basically the two important halves to JPA, right? You've got your entity manager. That's how you save and load all your data, and you've got your entities, which are annotated as such. Right? So let's go ahead and do some of the work that we wanted to do. Let's do the address repository first. Okay. Let's go ahead and try to do this work. So let's do this together. Let's do the first step together because the first step is perhaps somewhat unintuitive. The question is, where do you get an entity manager from? Right? I mean, that's like the thing you need to start with. Where do you get an entity manager from?
Factory.
Yeah, an entity manager factory. Well, okay, where do you get an entity manager factory from?
That'll be static, right? You just import
Yeah, you would hope so, but no.
No?
No. No, you need to get the entity manager factory from your persistence context. And so the way that it ends up working is we'll say private final entity manager em. So this is our entity manager is equal to, here we go, persistence dot create entity manager factory, and we have to say which persistence unit, so it's going to be training, dot create entity manager. And that's where we get these from.
So the basic idea of the persistence manager factory is that it could be handling multiple databases.
Could be handling multiple databases. You could even have a single database that's partitioned into multiple persistence units. Yeah.
What would that correspond to in the database parlance?
Nothing.
It's just a logical.
It's just a logical separation at the object level. Yeah. Okay. So this will be good enough for now. This is actually subtly incorrect, but we won't care about that subtlety for the moment. So this is how you would create an entity manager. All right. And oh, I'm still running actually. That's not good. All right. So that's step one. Step one, we're good. We've got an entity manager.
Do you ever want more than one entity manager?
So the short answer is no. Like ideally, you really actually only want one singleton entity manager. For what we're going to be doing, it won't make a difference. We'll start to run into problems later. So we'll keep it like this for now. Okay. So we've got an entity manager. What's next? What's next to do?
Who provides that persistence object?
This persistence.createEntityManager factory is just a static method, right?
Yeah, which package provides that?
Java x.persistence. This is all part of JPA. The Java persistence API. Yeah, so delete the constructor because we don't care about initializing a data source anymore. All right, what's next?
This training needs to be there in the XML, persistence.xml, right?
I think we've put it.
Yeah.
Yeah, and that's exactly what this is referring to, right? Delete init, yeah. Feels good, right? Okay, how about find? How's find gonna work? All right, well, first of all, what did we say? What was in our to-do list here? Yeah, all right, so instantiate an entity manager, done. Delete constructor, done. Delete init. Delete the setup. Well, we'll get back to that one. Okay. Yeah, so all this throws SQL exception. I'm just going to go ahead and delete all of those now, just so I don't forget. So throws SQL exception. I'm going to go ahead and hey. There we go. Yep. All right. That felt good. All right. We can also delete all of the body of all this stuff, so all this try finally business. All right. So how does this work then? I had you guys look at the Java doc for Entity Manager. So yeah, just return em dot.
The find, should it not be the object long rather than a entity long?
It's surprising how many of you guys have asked that question. It's funny. Why would it need to be the object long?
Because we're defining it as object, right? Initially.
In the entity we are, but when we want to actually do a find, like we don't want to pass a null ID. Like finding an object with a null ID doesn't make sense, right? it's going to auto box that to be a long.
Okay. So we don't need to worry about conversion.
Yeah, we don't need to worry about that. All right. So find. All right. How does this work? Have you guys seen this like class T thing before in Java?
You need to give the address object.
Address dot class. Yeah, and so that's what says what type this needs to be, right? And ID, right? All right. How many lines of code did this function used to be? Yeah, well, yeah. Anyway, so what's this doing? This is doing all of our unmarshalling, right? Or which was which? Yeah, unmarshalling or deserialization, right? Yeah. All right. Now let's do create together as well. Actually, we said create and update. We were just going to merge those into one save method, right? Save. So what's save going to look like? Yeah. So em.merge, right? em.merge address. All right. We're gonna find some problems with this. All right. But I'm gonna leave it like it is for now. Okay. Like this code, we're gonna see some exceptions, and that's fine. I really like teaching that way, just to to try the code that seems most obvious, and then to find out why the most obvious thing isn't right. This is unfortunately a common pattern in Java enterprise development. Is the most obvious thing is usually wrong.
Do we have a variant in find where we can search for some objects not on the primary key? But
Yeah, we'll be able to do that.
there, do we need marshalling?
The entity manager does everything for us. Yeah. All right. How about delete? em.remove address. Yep. All right. Not bad. And this unmarshal method can go away as well. And suddenly our repository is looking a lot nicer. Right? All right. So, I mean, is there anything in this class that's like really specific to addresses at all anymore? I mean, we could make this generic, right? Just some base repository for some type T, right? Yeah. All right. So let's do some refactoring then. I'm going to make a new class. And we'll just call it repository. Right? Just repository. And repository is just going to take some element type E, right? So I'm gonna just copy and paste this stuff from address repository because it's going to extend. Right? So repository of type E. Well, if you do find, it's going to return an E. If you do save, right?
E.class.
Yeah, so E.class is a problem. So any of you Java gurus know why you can't do this?
You don't know what class it is.
We don't know what. Yeah, why not? Yeah, at runtime we don't know what class this is because of. It's a word that starts with E, also actually. Erasure.
What's that?
Erasure. Type erasure. The Java compiler, when Java is compiling generics, when Java C is dealing with generics, the type checker runs, so it makes sure that at compile time it makes sure that our types line up, right? If we're you know, putting bananas into a set of bananas, we're not trying to get apples out or something like that, right? So it makes sure all the types line up at compile time, and then when it emits the bytecode doesn't have any generic types in it at all. It forgets about all of them. So all of our generic types all turn into object. That's why we can't do e.class, because this would be some sort of a runtime value that we just don't have anymore. So we do need some kind of constructor, or maybe like an abstract method or something like that. So so let's say we have a constructor that, well, let's say we have a field, private final class of e entity class, and our constructor needs to take that entity class. Why am I doing this? Here. There we go. All right. This is now our generic repository. So not too bad. Like I said, we've got some bugs here, but we'll find them. Right. All right. So now that we've got this generic repository, how do we implement address repository?
Just repository address.
Yeah, address repository extends repository of address. Right. What do we need to do?
What do you need to extend it into a class? Can you just use it like that?
Well, we could just use it like that. We could just say new repository of address and pass the constructor. But I like to do it like this. It'll be a little bit more consistent with what we'll end up with Spring. So I'm like looking a little step ahead. So I'm cheating. Super address.class. All right.
What is that? The super address.class?
We're providing a default constructor for address repository. So we can just say new address repository, but we have to pass in that class object, right, in the super constructor. So that's address repository.
In this particular case, it's okay. There's none of that erasure thing.
Right, because we're dealing with a concrete class. It's not a generic type.
Oh, I see.
Yep. Yeah. So this runtime value, we know what it is. It's the class object.
This is going to call that entity class, right? This is going to call that entity class and initialize it.
Well, this isn't actually going to do any of the initialization. Hibernate, just sort of on its own, is going to go figure it out, right? Any of this stuff, like this, this code that we've written, like this will happen whenever we call it, but any of the initialization will have happened beforehand, at some point. We don't even need to worry about it.
Now, who's going to call the constructor for this repository class?
We will in the same place that we say new address repository right now. So in our controllers right now, we're calling new address repository or new contact repository. So we'll do the same thing. We want our API to be basically the same. We just want the implementation to suck less, right? All right. So this is our repository for now. How about, so this is address repository. We want contact repository to be similar, right? How are we gonna implement contact repository? This is my favorite part of the whole class.
The same as address repository.
Yeah, same. Yeah, so exactly. Here we go. I delete about 160 lines of code. That's always good. Repository of contacts. right? All right. Okay. So this is good. Oops. I've done this in the wrong. Oh no. Oh. All right. Well, point being, we don't have a lot of code anymore, so that's good. We have some things we need to change though. All right. So first of all, setup, right? Let's see. We need to delete that setup web listener thing, so we can just go ahead and delete it. Yep, delete the file. So that's gone. Yes, deleting code. Right. Okay, contact servlet. Right. So contact servlet, we can see that the beginning of it up here, you know, where we create our repositories, that API is still the same, right? New address repository, new contact repository. We've kept that API, right? There's a few things that we've broken, some of which that we're very happy about actually, like catch SQL exception. Hey, we don't have to do that anymore. This is the only thing that I like about checked exceptions. See, the thing that I dislike about checked exceptions is that the compiler forces you to catch them if it sees that they can be thrown. So I dislike that part. The part that I do like is it prevents you from catching them if it knows they can't be thrown.
That's the more of a Eclipse part, right? Or is it a compiler?
It's, yeah, Java compiler. Yeah. The compiler says unreachable catch block. This exception is never thrown. Yeah. So we can delete this try catch, which makes things substantially simpler. And when it gets to the point in the day where I start talking gibberish, it's kind of all over. All right. So that's one. Here's another try catch. Another try catch that we can do away with. That's pretty good. All right. Okay, create.
Can you open a contact repository?
Sure. Well, contact repository, you won't really see anything. Or, oh, this is what you wanted to see, right? Yeah.
From the context servlet, we removed the annotation web servlet?
I'm sorry?
Did we remove the annotation web servlet from the context servlet?
No.
Okay.
No. Our servlets are basically going to be the same. Yeah, basically, you know, we'll change a few things just to adjust to the new API, but they're still servlets. We're not doing any Spring stuff yet. Maybe start with Spring tomorrow-ish or so. We'll see. Probably Thursday. Okay, so back to contact servlet. All right, so create doesn't exist, right? Create and update are now just save, right? So save, 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 right? Okay. So far, so good. We can do the same stuff in the contact list servlet. But we have a problem with the contact list servlet, which is we haven't implemented find all yet. So I'm going to give you an actual coding exercise. Let me check in the code. I know that this code doesn't compile right now, right? Doesn't compile yet. But your exercise is going to be to make it compile.
Did you remove the setup.java file?
Yes. Yeah. So let me check this in, and I'll explain again in a little bit more detail what I need you guys to do. Let's see. I can do git add -u, can't I? Yeah, there we go.
So add -u.
It also looks for things that have been deleted and stages that for commit. All right, so oops. All right. There we go. Okay, so I've just pushed this. Like I said, this doesn't compile, and the reason why is because find all doesn't exist. So your assignment is going to be to have another look at the entity manager class and see if you can figure out how you might implement find all. It's not going to be like totally obvious. There will be some questions you'll have, but I want to give you guys a start with that. First thing, obviously, just stub out the method. Yeah, so what have you guys found?
Pretty cool.
Yeah, great. Yeah, well, yeah. Probably the biggest hint is that since I've clicked on this at some point in history, this is probably the right answer. The link is purple, therefore it's right. Yeah, so create query. You can get a query like this, just a raw query object, or you can get a typed query. What do you suppose the difference is?
Like would be the query address or the
Since we're having a criteria query, the template, is it going to give you the exact object?
Well, we don't actually. This isn't the one I'm going to use. We'll use this one that just takes a string, or this one. So just between these two, let's say that these are the choice that we have.
Does it have to specify the class of the result?
Yeah. So it would be specifying again for static compile time type safety, right? We want to be able to specify the class that we're getting. So query, excuse me.
One question related to this.
Yes?
So what if I specify one class but then my query returns a different entity?
I don't believe it can.
No, so I mean, do I expect an exception, or what would happen?
You'll get so it depends on what you put in your actual query, like in your JPQL.
I mean, the example here, right, is if I ask
So for example, if you ask for addresses and you give it contacts, you get an exception. I'm pretty sure it's an exception and not just like an empty result set or something stupid like that.
So this query versus the other one, I guess if I don't know the type, I can provide a query and then on the return
And then
object,
cast
I will
it, cast it
run
later.
the instance off and then figure out what.
Yeah, exactly. So a regular query, like just query. Let's see. Well, how do we get the results from a query? There we go. This is what we want. Get result list, right?
Yeah, just get single result versus get result.
Yeah, single result or get result list, right? And you notice this is a raw, unparameterized Java util list, right? This is not a Java util list of anything in particular, right? It's a list of just objects. We don't know what they are. Whereas with a typed query, you can do get result list, and it'll give you a list of X, right? A list of some particular type, right? Okay, so that gives us a hint then, right? If we go in our repository, we want to implement some sort of public, list of find all.
Do you do it in the implementation, the contact repository?
No, I mean because it'll probably be useful for other things as well. It doesn't hurt us to have it for addresses. There might be some reason why we want to get all addresses. Yeah. So find all, and that's going to look like what? Return em dot create query, and we have to pass it some sort of a string. So we'll get back to that in a second. Either a string or a criteria query. Dot get result list. Right. Oh, and we want the yeah, that needs to go second. Right. Oops. All right. So here's the question. Create query can either take a string or it can take a criteria query object. In either case, basically we're trying to assemble an actual query. So this is going to be like, select star where something equals something, or this will be like, an actual query of some sort, right? This gets to your question, like how do we queries that aren't just by the primary key, right? So there's two answers to the question, right? One is we can pass in a Java persistence query. This looks similar to SQL, sort of similar to SQL, but it's a little bit different. So we'll talk a little bit about JPQL. Another option is we can pass in one of these criteria query object things, and you'll see that this gets very complicated very quickly. So we won't be really getting into it, but just to kind of give you a glimpse. A criteria query is basically a domain-specific language for building query criteria, like group by and having, order by, right? Select, things like this. Right, and this is an interface, so like, where do we get these things from? Gets funny. So we need like a query builder of some sort.
There isn't a link. Are you familiar with link? LINQ?
LINQ, yeah, there isn't. Because Java isn't expressive enough. Right. Now, since you asked, and you asked the question before about like, what would you do in Scala?
Yeah.
Or what would you do, yeah, or like what would you do instead of Hibernate?
It's like link.
Something like link.
Oh.
Yeah. Yeah, something just built into the language that'd be, or something that you could at least express in the language. That'd be a lot more.
It's interesting that after several decades of language development, nobody thought about using a select style statement within the language construct, right?
Yeah, well. Anyway, I hope you enjoy the Martin Odersky's Scala course.
Yeah,
it'd be interesting. Okay, so we're not going to worry about criteria queries. We'll use JPQL because it's going to be the easiest thing for us. Basically, for us, our query is just going to be from and then the name of whatever table. Oh, so what are our table names?
Address.
Yeah, so address or contact or whatever. It's going to be the same as the name of the entity class, isn't it? So
Plus.
yeah, so entity class dot get simple name. Yeah. So that's going to be our query. It's probably easy enough. That's what find all ought to look like. Now, what's the issue over here? Right. Okay. All right, so we have a number of problems, but we'll have to discover them one by one. Let me check this in. I want you guys to be able to actually run this and try it out and play with it and see what's wrong. Let's see. All right. Yeah. Okay. So I've checked this in. Am I recording right now? Yes. All right. So I've checked this in, and your next assignment is going to be to try and run it and see what breaks. See what breaks, and then we'll talk about how to fix it. Right. This is, again, things we talked about before, like how do you generally set up a project? Well, you copy and paste from a previous project. Okay. Likewise, how do you learn JPA or how do you learn Hibernate? By having stuff break. Yeah. So this is the actual learning process here. And it's probably the best post lunch learning process is to just do a bunch of stuff so you don't fall asleep. Okay, so everything doesn't work, right? Try to run this. Oops, try to run it the right way. All right. First thing we notice, by the way, when we run it, even before we try to actually do anything useful, is that we're actually getting some information about Hibernate, right? So we know that Hibernate is being loaded by Jetty, so that's a good thing, right? This is kind of nice, right? It says that the let's see, what does it say? Well, all right, actually, it's not telling us anything useful, so never mind. All right. If we then go over to our contacts page, we run this, and we get an exception. It says contact is not mapped, right? We're trying to do this query, right? This query that just said from contact, right? That query, by the way, it's very similar to just saying select star from contact. You don't have to do that in JPQL. You just say from contact. That's enough. Yeah. Or you could say select from contact, but the star doesn't mean what you want. So from contact, but contact is not mapped. Meaning we haven't actually said that contact is an entity, right? Matter of fact, if we go over here, and let me try to refresh the project here. If I look at my training database, what's there? Absolutely nothing, right? I look at trainingdb.log and nothing is there, so that's no good. Right, we need to say that contact is an entity.
Annotate it.
Yeah, so we have to annotate it. Now, I'm going to give you the assignment to just do it. with the information that you have so far, right? I've showed you where to find these annotations. I haven't told you what they mean yet. I haven't given you any sort of formal information about them yet or anything. But I'm going to say, I'm just going to give you the assignment: annotate contact and annotate address, and see what you get. See what you come up with. All right. So what do I need to do? I need to annotate contact with entity. Yep. Entity. Yep. That's it. I can also say I can also put a at table. Is that what you're mentioning? Yeah. If I want to specify some specific information about how I want this table to look, I can do that. But it's not necessary. I'm going to just leave it out for now. Yeah. So entity.
Where would you put the table name though?
Hmm?
Where would you put the name of the table?
It just figures it out. It uses the class name. Yeah. Yeah. Uses the class name. If we wanted it to be a different class name, then we would have to make a change to our repository, because find all is using the class name.
Okay.
So our code is it's a little bit brittle, but. Okay, so entity. So contact is an entity. Address is an entity. Right? All right. So let's just do both of these at once, right? ID. What should ID be marked as? Could be marked as column. Even better, mark it as an ID. I haven't told you guys that one yet. It's an ID. And we want that ID to be automatically generated.
Do you have to be on top of that private or right?
It can be right next to it. Yeah, that's fine. I really like it to be right next to it, but when Eclipse auto formats, it splits the line, so I'm like, whatever. I don't care enough. So ID, and in fact our IDs are auto-generated, right? So we can say generated value. It's a generated value. Yeah. All right. What's street? What do we annotate street with? Yeah. Column.
You can also do at basic. What is that? Also creates a basic column, right?
I don't know what basic does.
That's what I did.
Just at basic?
Mhm.
Oh. Does it
says
it works.
gives you basic column.
I have no idea what a basic column is, as opposed to a normal one. I don't know.
Well, that's what I tried, and it created column.
Okay.
So what do you do in Eclipse that will automatically get the imports and everything in a single stroke?
I just autocomplete. It just
That's it?
control space. Yeah.
I think you can also do Control Shift O.
Window shift on. Control shift.
Yeah. Control Shift O organizes imports. I do that a lot. Yeah. Yeah. So this is just about all that we have to do for address. Here, let me save address so you guys can see this work, right? I'll save address. Things will restart on us, right? And I can then look in my trainingdb.log, and here we go. Check it out. Hibernate just picks it up. It says create table address ID big int. All right, so we had integer, right? ID big int generated by default as identity. These start with 1 for whatever reason. I don't know. City, state, street, zip, right?
So you also annotated the methods?
No, I just annotated.
Just the field.
Yeah, I just did the fields. Yeah. So we got city, state, street, zip, and it also says primary key ID, right? So, awesome.
How do we make sure that it doesn't recreate the tables every time?
Good question. Let's just watch and see what it does. All right. So contact. What do I need? ID, yep. Generated value, yep. There's also, be careful, there's also an annotation that's just called generated, but that's a different, that's from JavaX.annotation. That's something else. Column, right? And we'll say address ID is also column. We haven't really seen how to relate these things to each other yet, so we'll save that for another step.
So
All right.
the foreign key thing we'll do it later.
Yeah, foreign key. We'll figure that out in a little bit. All right. Okay. So I'll save contact, and here we go. Jetty's gonna reload itself again, and we'll look at the trainingDB, not the lock file, the lock file. trainingdb.log, and sure enough, it creates the contact table. Now, to your point, right? It didn't recreate the address table.
In fact, the first time I created the contact table, I didn't have this generated ID annotation, so it created.
So it created it, and then it did alter table, right?
It didn't. It should have, right?
It probably should have.
No, it did not.
That
I
sucks.
only see address table getting generated, but it did not change the contact table.
Have you saved the contact table? Sometimes it does get screwed up. Like,
Yeah, it is a save.
yeah, all right. So yeah, sometimes it does get messed up,
Yeah.
and that sucks. But it's still better than what we had before. So right, this is doing stuff for us. In fact, let's say I was to add a field. I don't know. Let's add a field to contact, like add column private string phone number, something like that. So I'll save contact, and we'll see what happens in our database log. And here we go. So I added a field. Hibernate figured out that there was a difference. It said alter table.
Some change it picks up.
Yeah, so some change. Well, so here's one thing that it's not going to pick up. Watch this. If I delete this column, it may not pick up the change. I'm not sure. Let's find out. Oh, maybe it did.
Disconnect.
Oh yeah, no, it didn't actually change anything.
Yeah.
The disconnect is an error.
No, disconnect is just when the session, when the connection disconnects.
So deleted a field and it did not pick it up. That's what you said?
Yeah, so I added the column and it picked it up, but then I deleted the column and it didn't pick it up.
That's bizarre.
Yeah. I know why I didn't pick it up. I'm sorry. I actually told it not to. Sorry, I'm like, yeah, it's broken, it's terrible, but I actually told it to do that because in persistence.xml, I said only auto update columns, don't auto delete. Yeah, so that was actually a configuration option. All right, anyway.
How does Hibernate know when to run and stuff like that? So what triggers it?
Basically, the first time you try to do anything, it'll lazily load, and when it loads, it has to go and check its own consistency, right? So it'll check and see, do the columns in my objects match up with the columns in the tables? So
So it'll basically walk from the entity manager onwards, introspect on all the classes and figure out the.
Yeah, it doesn't even really need the entity manager for that, but yeah, it'll introspect on all the classes, right?
Yeah, so
this is all of these annotations are being used by Java Reflection, right? Right. That's essentially how this stuff is working. Essentially.
But how would it know? There may be like 1,000 classes, right? How would it know which ones to go and introspect?
Anything marked with entity.
So it'll have to actually.
It actually has to walk the whole freaking class path. Yeah.
How come that's not slow? Is that slow?
It is slow, but it's a one-time cost.
But once it does that, auto-generates code, keeps it ready, or
it auto-generates code, yeah. So I said just now, I told a small lie, which is I said that this is all based on Java reflection. Well, Java reflection is extremely slow, usually. It's actually not using Java reflection technically. It's using bytecode manipulation instead. So this is like sort of proto AOP style stuff, like aspect-oriented programming. It's using a library, and you can see in, oops, you can see in the log here somewhere. Probably if I go all the way up. Come on. Oh wait, here. There we go. You can see in the log, like the first time when we actually start this thing up, Hibernate builds what it calls a bytecode provider. And there's a few that it can use. It can use something called ASM, or CGlib, or JavaSys. So it's using JavaSys here by default.
what is that JavaSys?
It's a bytecode manipulation tool. So what it does is it takes the class files that we've created, right, our entity classes, and JavaSys will allow Hibernate to mess with those classes at runtime. So it'll inject bytecode into the getter methods and the setter methods to keep track of state.
Do that at runtime, or to auto-generate and reload it at runtime?
At class load time.
Load time. Okay.
Yeah.
So it'll create some temporary classes?
No, it manipulates those classes directly in place.
And that's pretty much how Spring works, right?
And that's very similar to how Spring's DI works. Right. Okay, so we can see that this is actually doing something, so that's good news. All right. So if I go back over here then, and I load contacts. Okay, so my contacts page actually works now. Right, find all is not returning anything, but at least it's not throwing an exception. It's also not returning anything because we don't have anything yet, so that's correct behavior. All right, so how about add a new contact? Let's add derp, because derp is great. This happens to be the address of our office in San Francisco. Ah. No? No. So this one's a little trickier. This one's a little trickier. Let's look at, let's see, where's this happening? Contact servlet do get line 32. Contact servlet line 32. Here we go. So we're getting a null ID. And how are we getting here? The JSP page is, we know that the JSP page is fine. We've had all this stuff working. So the only place where we could have a bug, but this is the reason I like structuring the class this way. The only place that we could have a bug right now is in our repositories, or something to do with our repositories, because that's the only thing that we've changed, right? Our repositories, or maybe our entity, but probably not.
Here it seems we are getting the parameter, right?
There's no parameter ID, right?
And we are not really, we are passing it.
We should be. So this, remember how these JSPs work? Is we submit we submit the request and then it redirects. Remember that? So if we're in do get, it means that the submit worked and it's redirected to do get, but without an ID parameter. So that's weird, right? Why would it be null? So we've got to do some debugging now. All right. Again, I know the reason why this isn't working. You don't. So we're going to go through this. Let me stop the running process right now, and we'll actually open this in the debugger. Let's do this. let's do this. We suspect that the problem is probably to do with save, right? And who's calling save? Like if we're trying to add a contact, well, it's going to be in the contact servlet, right? Save. All right. So here's where we save stuff, right? In the address.
Assuming that the already is empty, is already in the database, and it's trying to retrieve it or something. The merge operation, merge API, does it assume that the entity is in the database it's trying to retrieve it?
Can you see
Maybe.
the database?
Can we see the database? Yes. Very good question. Or very good idea. Here we go.
It's not there.
It's not there.
So that's why its ID is not.
No.
Oh, it's not committed.
It's not committed yet.
It's not committed.
Yeah. Okay. Well, so let's have a look, right? Let's actually run this in the debugger to make sure that our theory is sort of correct, right? I'm going to debug, run this in the debug like this. Here we go. So I've set a couple of breakpoints. Oh, come on. I know. Why can't I ever get rid of this window? Kind of like, yeah, there we go. Okay, so I've set some breakpoints in do post on contact servlet, right? In this save and in this save. Yeah. And then, I mean, actually, this is probably the best place to set the breakpoint. I don't even care what save does. I just want to see what the state of these things are after we save. Right? So let's go ahead and try to do this. I'll add this contact, switch to debug perspective. Here we go. So sorry, my screen real estate is a little limited here, but hopefully you guys can see that we are, so we're in do post. We're about to send this redirect.
Contact object.
And yeah, what we want to look at is the address object and the contact object, right? So address, okay, so address has the city and the state and the zip, all that stuff, but it doesn't have an ID.
Yeah, that's because you were pre-populating it in the previous case. After we were doing a query, right, to get the ID.
Not a query, but we were, remember we were doing the get generated result or generated keys thing.
Yes.
Yeah. So we haven't done that yet, right? We haven't done anything like that. And similar problem with contact, right? Contact has all the fields that we wanted to put, but it still doesn't have an ID. So when we try to redirect to this contact with ID something, it doesn't work, right? Contact ID equals null. That's no good. Okay, so
why is it not persisting?
Yeah, why is it not persisting? That's the right question. First of all, I know a couple of you guys are following, but is anybody feeling lost right now? Because this is starting to talk about a little bit of a different model from what we're used to, right? Before, when we said create or update or whatever, right, in our repository, when we said create, it would save the thing to the database immediately. When we do merge, it's not. So, what gives?
Committing?
Yeah, it requires you to explicitly commit. It's not going to assume that each of these things are atomic. It's going to assume instead that you're probably doing some sort of a transaction, right? Do you guys understand? So it doesn't know when we're done doing stuff. Right. Does that make sense? Is that okay? All right. Cool. So let me stop running for now. Go back to our Spring view. Yeah. Anyway, so we can see the problem is our IDs are null. That's no good. Okay. So we need to commit, right? Committing is, we seem to have a fear of commitment or something. So basically, anytime we do save or delete, right? Delete, we're probably gonna have the same problem, right? With delete, anytime we save or delete, we need to commit something. So how do we do that? That's your next assignment is to figure out how you commit this change. And the correct answer to the assignment might actually be like go to Google and find an answer on Stack Overflow or something. But that's fine. I want you to know how to look this stuff up. I mean, I should say, like this isn't just me being like a lazy teacher. There's some good resources on the web for JPA, and some like complete crap resources for finding out about this stuff. Anything on Code Ranch is terrible. Things on Stack Overflow are usually pretty good, right? Anything under the actual Hibernate documentation, like JBoss and Hibernate documentation is generally good, right? Yeah. So part of the class is to be able to find answers to these because I guarantee you, as you're working with Hibernate. I mean, never mind Spring. Spring has its own set of issues. As you're working with Hibernate, you will run into some really weird behavior sometimes. Just some totally impenetrable, ridiculous situations that you need to find answers to. So I do want you to get in the habit of looking this stuff up. Start recording again. The question was let's talk a little bit more about these annotations, right? When we had to write out the schema ourselves, right? When we said, create table, contact, and then, to specify all the fields and stuff. Hi. Oh, you have a new projector. That's excellent. Okay. Yeah, I guess if you just put it there, I think that's perfect. Thank you. Excellent. Yes. All right, I'm going to keep going anyway. Pardon the noise. So when we constructed,
Can I put it here?
sure, yeah, if you like. Yeah.
Power too.
Yeah. Can use power. Can use power right there. Yeah.
Okay, use that whole power strip right there.
Yeah. So when we constructed the schema, we said create table, contact, and we had to say all the the DDL for creating the table by hand. What did that look like? Well, I mean it looked like this, right? This ID something generated by default as identity. So we need to signal to Hibernate how to create these tables correctly the same way that we did it by hand, right? So we need, there's a couple things here in this SQL. This generated by default is identity. That's what happens when we say generated value. And when we say ID, the ID annotation, that means that field is the primary key for that table or that class. So that is what that means. This ID says it's the primary key. Generated value says it's a generated value. Okay, are you ready to go with that? All right, here we go. We're going to do a big projector switch. Oh, and you know what? Just leave it off for now because actually I'll do it during the break because my screen recording is going to freak out if I
Okay. Yeah.
yeah. Thank you though.
That's okay. Just let us know if there's a problem.
All right, much appreciated.
It should be fine.
And this is going to be blinding me for now, so power this down. All right. Hopefully we'll get this good. Thank you again. All right. So, does that make sense? All right. I think it's just cooling down now. It's like it's mandatory cooldown period. Yeah. Okay, so so again, what was your assignment? That
Find out how to commit it.
oh yeah, find out how to commit a change to the DB. Did you find out? Oh, how?
Get transaction.commit.
Get transaction.commit. Okay, good. All right. So let's keep moving then. All right. So let's go back to repository. So em.get transaction.commit, right? All right. We'll just do it for save for now. We'll assume that's good enough. And
more changes, right?
Hmm?
You need to make more changes, right, to the servlet.
How?
The
Where?
object is not going to be filled up, right? How are you going to get the ID?
How are we going to get the ID?
Again,
Good question. Yeah, we'll have to fix that problem as well. The first thing that we noticed though was that, like, you know, we weren't getting any inserts, right? We want to at least make sure that in our DB log, right? This is actually a very useful debugging tool for us, right? We want to make sure that in our DB log we see an insert, just the way that we had it before. We want to see that insert. Because when we do the insert, that's when we find out what the ID is. Right? That's the only way that we can find out. Okay?
So instead of the commit, what if you did like a flush and set the flush mode type to like auto?
A flush would be another possibility. Let's try that first. Actually, I'll comment out the commit em dot.
It's less like nice, but
I think it's reasonable, right? Because flush, if you look at the Java doc,
yeah.
synchronize the persistence context to the underlying database, right? That's kind of what we want, right? That's like the easiest sounding thing. So let's try that as a first pass, right?
Is it that when you use flush and you don't have handle a transaction, you cannot roll back versus if you do transaction commit, you can.
Let's find out. Let's find out. All right, so let's try running it. Oops. Let's try running. Oh, come on. Actually, let's try running it in the debugger. Just no, just run it normal. So I'm feeling indecisive. All right, here we go. Let's try to do this again. Hit add. No transaction is in progress. Yeah, so flush wants you to be in a transaction. So that won't work, unfortunately. All right, so back to the drawing board. Let's try this other one.
One more question.
Yes.
So on transaction there is also begin. So can you like start the transaction and then flush or no?
Start the transaction, then flush.
Or you have to do the transaction.
Yeah, I mean, I think let's yeah, we'll try bit by bit here. Yeah, so we'll try transaction commit. Probably that won't work either because we don't have a transaction. Yeah, so em.get transaction.begin, right?
So like, when would you use flush then? If you essentially like you need a transaction to begin with, you might as well just commit.
You typically don't need to flush.
It's kind of just like forcing it. Like,
Yeah, it's kind of just forcing it.
would you commit and then flush maybe if the commit like doesn't actually go to disk or something?
Commit has to go to the disk.
Well, if you go to like a journal layer, for instance.
I think you might. You're actually over my head. I don't know. I don't know. All right, so let's try it this way. All right, so we fixed our no transaction problem, but we still get this null ID, which gets back to what Hamish was asking about. All right, so let's do this. Let me stop. I'll run this in the debugger again.
Can you see the DB?
Oh yes, yeah. Thank you. Yeah. All right. So in the DB, we can actually see that we've inserted this thing correctly. Yeah, that's an important point. We start the transaction, we commit it, we do the merge, we commit, and we get something in the DB, but the ID in our object is still null, which is, well, it kind of sucks, right? If we had used persist, it would have worked. So that's I could show you that working. Persist is generally the wrong answer though. So I want to show you a different way. Here, let's go back to contact servlet.
Yeah, that just sets it to an auto or not.
All right. So we'll run this in the debugger now. All right. So here we go. Running in the debugger.
What have you changed? Persist?
We haven't changed anything yet. Like we still have this null ID problem, so I want to see if we can see why. Let's do add again here. Here we go. All right. So yeah, sure enough, we've committed to the database, right? So the state of the DB is correct, but the object that we have is not.
That's not from the database, right?
Yeah, the object that we have, so this is where we need to be careful about the things that are in our persistence context and the things that are not. And this is where JPA is a little bit fiddly. All right, how did we, let's take a sort of a deeper look at contact servlet here, right? This is the code that's being invoked, this block of code. So we construct an address, we construct a contact, right? We're constructing those things ourselves, right? We say new address, new contact, right? Boy, those were some mighty straight lines there. Yes. Right? We say those things ourselves. When we say merge, that's all well and good. It says, if you go back and look at the Java doc for, hey, oh man, come on. All right, well, whatever. Oh, I see. I'm still in my drawing mode. So if we go back and look at the Java doc for merge, it says merge the state of the given entity into the current persistence context. So, I mean that's a little bit weird, right? Like this entity that we created isn't managed right now. The address object and the contact object that we created are not managed by Hibernate. They're managed by us. We just said new, right? We want to merge the state of these things into the persistence context, whatever that means, but the objects that we have are not managed. So here's a little bit of a hint. I can't draw anymore. Yeah, it returns a fresh copy of that object. A fresh copy of that object that is managed now. So this is a little bit different. We have a change to our API that's is going to require us to make a small change. Now, like I said, the alternative is to use this method called persist. It says make an instance managed and persistent. But there's a possible danger with that, which is that we can get into situations fairly easily where we do it multiple times by accident. Where if we try to save the same object multiple times, several copies will end up in the DB. So we want to make sure to just merge. Okay.
So it's not idempotent.
it is, well, what's going on? I can't seem to, wow. The awesome thing is here, can I, yeah, there we go. It is, yeah, persist is not idempotent. Yeah, correct. Yeah.
Is there an idempotent operation?
Merge. Yeah, merge is. Okay, so so let's go and fix this. We need, where is it? Yes, repository. So save is going to do something a little bit strange. Instead of just merging, we need to actually return. Oh, sorry. Return the entity, right? Let's stop this from running. All right. So it's returning the entity. So that means that every place that we call save, we've got to actually make some changes.
Why would you want to make some changes? Unless you're checking for return.
Yeah, sorry, not every place, but every place where we need to know the ID of that entity that was created, we need to actually get it from save. Yeah. Yeah. So this is this is a different programming model from what we had before, right? Let me commit this, and I'll have you guys do the rest of the fixing up. I think it'll. Yeah, I think it should be able to work for you guys. So let's see. Yeah. Let's see. Annotated entities and fixed some bugs, but not all. Okay. So I'm pushing that, and your guys' assignment for the next little bit will be to basically get ourselves back into a working state again. You have a what's up?
There's some issue with mine.
Oh, all right. Let me pause recording then. All right. So I think the changes that I need to make as a consequence of this is just to basically find the places where I save stuff. So that'll be in the contact servlet only, right? Contact servlet. So save. Let's just find save. All right. So I'd have to say address is equal to address repository.save, right? And contact is equal to, sorry, contact equals contact repository.save, right? These entities that we get from the repository are now managed entities. These are entities that belong to the persistence context now, right? These are, in other words, these are objects that Hibernate is paying attention to, right?
They're of no use, right? Or the get ID.
The old ones are of no use. Yeah, the new ones should have an ID. Yeah. All right. Any place else that I'm doing save? Yeah.
You don't need to. Yeah.
Let's see. Yeah, I think we probably don't need to do it
No,
here.
you need to do it for the contact get ID. Further down. Yeah,
Here?
yeah.
You know what though? This is for editing an existing contact, and that the existing contact should already have an ID. So I don't think we need to. I don't think we should need to worry about it. The reason why, again, see up here, these addresses we were, new address, new contact, right? Those objects weren't managed. These objects, where we say find and find, these objects are managed. Yeah, so we should be okay with these. right? We can treat those as just regular objects. It's like I said, Hibernate is, or this whole ORM thing is like sort of a leaky abstraction. Sometimes we need to worry about what's going on with the DB. But in cases like this where we get something from the DB and do some manipulations and then save it, usually it's pretty transparent. Usually it's a good abstraction. All right, delete isn't going to work yet because we haven't fixed it, but that's fine for now. Let's say that's okay. So I hope this ought to work. I might have forgotten some things, but it works for you. All right, so let's give it a go then. Am I running already? No. So we'll do this. We'll get this working, and then we'll take a break because we want to talk after the break about relationships. There's all kinds of good therapy going on here. All right. So we've got our contacts page. That works. Add a new contact. Derp was probably good. Add it. It's there. Miracle of miracles. I can go back to the contact list. It's there. I can edit the contact. Hit edit. That's there. Back to the contact list. Yeah. I feel like I'm the Old Spice guy. I'm like, look down, back up, back at me. We're on 301 Howard Street. So, I don't know. All right. So this is working, right? And when it's working, when it's working, we can celebrate. So yeah. So we'll take a break, go get some drinks. But let's just before we take a break, I just want to kind of recap what we've done so far with Hibernate. Let's go back to our list of pain points, right? Which of these pain points have we resolved? Yeah, this is no longer possible, right? Our entity is just the object itself, right? Yeah, so that's not possible. One must know SQL. That's we had to know a little bit of this JPQL. Yeah. So not perfect, but much better, right?
Do you have to worry about performance issue like you're deploying production ready code?
Oh, well, that's a general question. I mean, no matter what tool you're working with, no matter what language you're in, you always have to worry about performance issues. Hibernate is no exception.
But you could tweak through Hibernate, or you have to actually go and tweak.
Yeah, there's some sort of techniques that you can do to tweak Hibernate a little bit. It still all boils down to database performance, right? So optimizing your database schema is still.
But Hibernate actually optimizes the schema design.
No, Hibernate takes you pretty literally. Okay. Yeah, Hibernate tends to follow your instructions very literally. But fortunately, the instructions that we give are at least at a high enough level that it's easy to do and easy to maintain. Yeah. Anyway, to answer your question, yes, performance can certainly be an issue if you have a naive design. Same as anything else. Right. How about this one? Have we dealt with this one yet? We haven't addressed this issue yet. So here, let me start this because that's what we want to do after the break. How about this one?
No, it's not an issue.
Yeah, this one is basically fixed. There is one spot in our deployed war where we do have to say which SQL implementation. Right? It's in that persistence.xml. So it's not perfect, right? If we wanted to deploy our WAR on a MySQL database or deploy our WAR on a some other database, we would need to have a deployment script of some sort that swaps out the persistence.xml. But at least in our Java code, there's no ties to a particular SQL dialect. Like I said, not perfect, but pretty good. We've dealt with this pretty well. How about this? Yeah, boy, did we deal with that, right? This one, yeah, we certainly dealt with that. We certainly dealt with this, right? We've dealt with this one too. This create table if not exists. So that's kind of nice. I don't even, to be totally honest with you guys, I don't know how Hibernate does it. Hibernate is able to see that the table is there somehow. You know, I don't know how.
Look up the database metadata, right? Table metadata.
Can it do? Maybe it can do that.
Yeah, you can.
Oh, so we could have done that.
Yeah, I mean, if
Oh, all
you
right.
put an extra code, sure, you can do it.
Yeah. All right. Okay. Yeah, fair enough. Okay, transactions. We haven't really we have sort of a fake transaction right now. We don't have a transaction that encompasses multiple operations, right? A save is just, we just say that a transaction is just good to make merge work. Yeah. So we haven't really dealt with that yet, right? Joins, we haven't really dealt with that yet either, right? And that's going to come into play here.
This is still to delete, right?
And yeah, we haven't fixed delete yet. Yeah. Right. Actually, yeah. Sorry. Edit, delete. Yeah. So delete doesn't work, or not correctly anyway.
It actually is funny when I edited the contact, then delete worked. I edited existed another contact, then it was gone. Yeah.
Yeah, there it is. Because then we did a commit. Yeah, then we forced a commit. Yeah, so we're kind of in a weird state.
That means it didn't require a transaction taken in commit?
Well, it does. I mean, it didn't work, right? The delete didn't take effect until later, which is not what we wanted. And it got like you can see that I got into a weird state where the persistence context was out of sync. So just a quick fix. Begin. Commit. One thing you notice, by the way, and this I've done this on purpose, but we hadn't really talked about it. I keep saying em get transaction, em get transaction.
Store it and then use that.
Should store it and then use it. That doesn't work.
It doesn't?
No, we have to get it each time.
Really?
Yeah.
There's no stack scoped objects or methodology in Java that would take care of that.
Not like this, no. When we start with Spring, we'll see how Spring deals with transactions, and those will be proper transactions. This is sort of we're faking it. Like I said, this repository is sort of busted in some subtle ways, but as long as it works well enough for us for now, we can kind of get the gist of what's going on with Hibernate. Okay. Any questions on the stuff that we've done so far? I mean, what did we do, right? We blew away everything to do with our JDBC code. We annotated our entities. We made some small tweaks, and we were good, right? So what's the net outcome?
Less code.
Less code, yeah. Less code, more maintainable.
Whenever we do this get transaction, we make a new DB connection.
I don't believe so. Anyway, we're using connection pooling, so it doesn't make too big a difference. Again, like I said, we're doing this get transaction stuff. That's like this is like kind of wrong, right? We're not using transactions the way they're meant to be used. We're just using it so that we can save and delete the same way that we used to be able to. So this is a little weird, right? Yeah. Okay. Cool. Let's take a break. We deserve it. Our code works, so we must therefore deserve it.
Quick question.
Yeah.
So how does Hibernate deal with like sharding and high availability
Oof.
issues?
Take the advanced class. I don't know. I can give you sort of a high-level answer, which is that I mean, fundamentally, Hibernate doesn't actually know anything about databases. Like it's relatively thin layer that just speaks SQL for you, so you don't have to. Because SQL, so actually, I mean, this is a fair thing to mention, right? What's SQL? What is SQL? What is SQL? It's a structured query language. What would we do if we didn't have SQL? How would we do databases if we didn't have SQL?
Programmatic.
Yeah, programmatically, right? We'd be writing this, we'd be writing some sort of programmatic code to put things in a file somewhere, and so it'd be very low level, right? So when I say what is SQL, what I mean is, well, SQL is actually an abstraction. And SQL happens to be a pretty good abstraction because it's based on the relational algebra, right? Anything that's based on math is better than things that are based on not math. So this is sort of by way of answering your question, right? Since Hibernate is just speaking SQL, and it's not actually doing anything really special. It's just speaking SQL. It doesn't matter what kind of database you're using. The database can be a remote DB, right? It can be distributed, and Hibernate doesn't really know.
Vertically sharding the data or horizontally replicating the sharding.
Well, how does it work if you were just doing it with raw SQL?
Okay, so so it's a combination of programmatic logic and SQL, right? Where you would have to figure out, okay, the user ID starts with K, so put it on this particular server.
Oh, okay. So if you're dealing with sharding that way, like at the user level or the application level, I should say, then yeah, you need to write the same sort of code.
There's no abstraction layer within Hibernate.
Not that I'm aware of. No. But again, if your database is encapsulating the idea that it's sharded somehow, I think you can set up certain databases to partition key space, right?
Right.
And if you issue SQL to those databases, it's transparent to you, like what the setup is, right?
You have to have some transparent layer, right? And it's not going to be at the SQL level. So you have to do it either programmatically or right. So if Hibernate is sort of simplifying this stuff anyways, right? If there is a layer...
right, yeah. So if you're doing your sharding programmatically, yeah, Hibernate isn't going to do anything to benefit you there, right? You still have to write the same programmatic code. I believe. I don't think that there's any special thing in there.
So it may not actually work because then if you have a joint table, your partitions may be different, right?
Oh, yeah. So that's, yeah. It might end up getting in your way. Yeah, depending. It might end up getting in your way. Yeah. All right, guys. Break time. Let's start up again just a little bit before 4. Okay.